Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Circus Maximus by Jeff Wajes. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Digits along a pink line must form a non-repeating group of consecutive digits, but they may appear in any order along the line. So you could have something like, say, 3, 6, 7, 9, 5, 4, and 8. And this would be valid because these digits form a set of non-repeating consecutive digits, 3 through 9, basically. You could not have something, though, like a 2 here, because 2, 4, 5, 6, 7, 8, 9 is not a set of consecutive digits. You also could not have something like 8, 6, 7, 9, 5, 4, 8, because 8 would be repeating on this Renban line, which is not allowed. And these are known as Renban lines. And using red, green, and blue, color all circles such that orthogonally adjacent circles are different colors. So what are orthogonally adjacent circles? It just means circles that share an edge with each other. So this cell could not be green because then they would be sharing an edge and they would be the same colors, and that's not allowed. And the digit inside a circle appears that many times in circles of that color. So say we had a 3 here, then we would have to have 3 more greens, or 3 total greens in 3 cells. So you could have 3 here and 3 here, but we could also have, well, okay, that's not a good example. Let's use 3 here. So if 3 were here, that means we would have to have 3 in 3 green cells. We could have 3 here and 3 here, and that would be valid. But we could also have a 3 here in a blue cell, and that would say we would have to have 3 3s in blue circles. So, right, so a digit inside a circle appears that many times in circles of that color. And those are all the rules. I can't speak. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. How many circles do we have? So that's always good to know with these circle problems. We have in row 1, 9. 9 plus 7 is 16. Plus 6 is 22. Plus 6 is 28. Plus 6 is 34. Plus 6 is 40. Plus 6 is 46. Plus 6 is 52. Plus 9 is 61. So we have 61 circles. How many digits can we have? So 5 through 9 can only be in one color. And the reason why is if you try to have more than 5, if you try to have 5 through 9 in 2 sets of circles, how many of those digits do we need? For 5, it's 5 and 5 in the 2 colors, which is 10, but we only have 9 5s in the grid. So that's why 5 and above can only be in one set, period. So that's 35 at most for those digits. 4 can appear in 2 sets. So that's 4 plus 4 is 8, and then you have an extra 4 floating around. 3 can appear in 3 sets, 2 can appear in 3 sets, and 1 can appear in 3 sets. So that's the maximum amount we can have. So 1, 2, and 3 is 6 times 3 at most, which is 18. 18 plus 4 times 2 is 8. So that's 26. And 26 plus 35 is exactly the 61 that we need because we have 61 circles. So therefore, every set we know has to be exactly in the most possible cells they can be. Okay, so let's just double check we have 61. 9, we're going to do it from columns though. 9 plus 6 is 15, plus 8 is 15. 9 plus 6 is 15, plus 8 is 23, plus 6 is 29, plus 5 is 34, plus 7 is 41, plus 6 is 47, plus 5 is 52, plus 9 is 61. So yes, we have, so every 3 is in a circle, every 9 is in a circle. Okay. So every 3 in every box and row and column is in a circle. Every 9 is in a circle. For 4 and 8, they are in 8 of the rows. They are in circles. 7 is 7 times in a circle. 6 and 2 are both 6 times in circles. And 5 is 5 times in circles. 1 is obviously 3 times in a circle. Okay. Okay. 1 is only 3 times in a circle. Where can it... It has to be, and it only is in green once. If we did not have 1 in any of the corners, that would mean you would have to have a 1 here, a 1 here, and a 1 here, and a 1 here. But that's too many 1s in circles. So one of the corners is guaranteed to have a 1. And that's the green one. So then we have 1 guaranteed here, or here, or here, or here. That would eliminate 1s from the rest of the columns. We cannot have 2 1s in the corners, because if we had 2 1s, the problem is they would both be green. So we have to have a 1. If we have a 1 here, we have to have a 1 in row 1 and in column 9. So that means 1 always has to have it. We have 1 in the corner, and then they must be on the edge of the grid for the remaining 1s. So if you don't have, if you're a circle in the remaining grid, you cannot have a 1 in a circle. We are guaranteed a 1 here somewhere, but these cannot be 1. So we have to have a 1 somewhere here on the edge of the grid, which means this is 1 through 7 to be continuous. Okay. For this to form a valid RAM band. Obviously, 1 cannot be here. 1 cannot be there. So we have a guaranteed 8 or 9 here. Okay. These 2 digits here have to be the remaining, have to be 2 of these digits there. Obviously, this cannot, yes, this cannot be 1 here. So 1 of column 9 is going to have a 1 on the ren band. If we had a 1 here, then this would have to be 1 through 7, and then row 1 would not have a valid 8 through, would not be valid, because this digit would have to be 8 and 9 for that to satisfy. Every unique digit appears exactly once in each row. So this cannot be 1 through 7 here, which means this has to have 1 through 7 here. So we're guaranteed, this can't be 1, again. So one of these 4 is a 1 here. So this must be 1 through 7 here. We are guaranteed a 1 along there, so this cannot be 1 here. Okay. So we have to have at least 8 here. So this must be 2 through 9 as possibilities here. This could be 8 or 9. It could be... It cannot... Can it be 1? No. This cannot... So none of these greens could be 1 ever. In the middle. So these are 2 through 9. Okay. Oh, that's interesting. Can this not be 8 or 9? I guess so. It could, actually. Because we could have 8 be here and then 9 be in the corner. And that would force 8 to be there. Or 8 to be there, sorry. And that could work. 1 cannot be in a circle here. So where is 1 in box 3? It must be one of these 3 cells. 1 also cannot be in a circle here, so where's 1? It has to be one of these 2 cells. Where is then 1 in row 1? It must be one of these 3 cells. So this cannot be 1 here. This could be a 1 here, so that is not... But the thing is, yeah, we know there's a 1 in a green corner in one of these cells. It could be still here, though. No, it cannot. If we have a 1 anywhere here, then we have the same problem, right? We'd have 8 cells requiring the digits 1 through 7, which would force 8 and 9 to be here. So this has to be 2 through 9 here. So we know either this is 1 in the corner. Okay, well, no, it can't be. Where is 1 in the corner? Where is 1 in row 9? It has to be here. So this must be a 1 here, which means this cannot be 1 in the corner here. So we have to have a 1 be one of these 2 digits. That means there's no more 1s here. And where's 1 in column 1? It has to be here, so that's blue. Okay. So then this 1 here has to be red. These are 2 through 7 here. We have to have 8 and 9 be on this red band here in column 1, so therefore this cannot be 8 or 9 here. Well, where is 8 and we have a 1 2 we have a 2 3 4 5 6 7 quad 6 tuplet in row 9, which eliminates 2 through 7 in the rest of the row. So this is 8 or 9. This is 8 or 9. All the 8s and 9s are green. Interesting. Huh. Okay, that's interesting. One of these is 8 or 9. This cannot be 8 or 9 because it's not green. We have 1 guaranteed 8 or 9 here. So this is blue. We have a red in one of those ones. Eight and 9 cannot be next to a green cell. So this is not 8 or 9. This can't be 8 or 9. So 8 or 9, one of them's, we have 2 out of 3 of these cells are 8 or 9. No 8 or 9 here, no 8 or 9 here. So same thing. We have 2 out of these 3 cells are 8 or 9. We could have 8, 9, 8, 9, 8, 9. That is possible. One is here, one is here, one is here. So where is one in box 7? Can't be in a circle. So it has to be here. So this is 1, which means this cannot be 1 here. Where is the 1 in box 1? It must be here, and it's red, because we have a blue one already and a green one. So that's red. This cannot be red. Okay, so all the greens, let's see if we can, yeah, make those green. This must be blue here. So that's blue. This can't be red or green, so this is also blue. These can't be blue, they're red or green. So 1 is here. Where is, so 1 has to be one of these 2 digits because it can't be in circles anymore. Where is 1 in column 6? Can't be in a circle, can't be here because of 1 in the row, so 1 has to be here. No 1 there. 1 is to one of these 4. Where is 1 in box 6? Can't be in a circle, can't be here, so 1 has to be here. There's no 1 there, so one of these 2 is a 1. That means this can't be 1 here, so one of these 2 is a 1 there. Okay. So that helps us with the 1s. 2, we have 6 2s in circles. 5 is the next one that has the least amount, but that's not really that helpful. Oh, this is red. We have blue here. One. Can this ever be 8 or 9? The answer is no. If this... Wait, that's not true. No, it could be. It could be 9. It cannot be 8. We need an 8 somewhere in this Renban here. So 8 has to be one of these 3, which means this cannot be 8. But we don't have to have a 9 on this Renban. So there is that. Interestingly enough, then if this is 2 through 8, then this would have to be 9, and that would have to be 9. Interesting. This cannot have 2 here, because we are guaranteed an 8 and a 9 here. So this must be 3 through 9. That means we're guaranteed a 2 somewhere here, which eliminates 2 in the rest of this Renban. So well, we don't have any information about these, so that's not really that helpful either. Hmm. Okay. 5, 6, and 7 have to be in colors of the same circle, or circles of the same color. That doesn't make any sense. Colors of the same circle. That would be interesting. Hmm. Again, 3 and 9 can only have to appear in circles. So 3 cannot be here. 3 cannot be here. 3 cannot be here. Does that help? I don't really know. Oh, these are not green. This is right. So one of these is green, guaranteed. That's interesting. Doesn't really help much, but it's interesting to know. Obviously green is here. These cannot be 8 or 9. Oh. Where are 8 and 9 in box 7? Again, well, never mind. Can't be 8 or 9 here because they're next to green. So these have to be 2 through 7 here. But 8 or 9 could be here, right? These are blue or red. We don't have to have an 8 here. 9 does have to be one of these 3 cells. That's interesting. Ah, where's 9? Okay, 9 in box 9 has to be one of these 2 cells. But 9 and 8. Oh, where's 8 and 9 in box 1? They can't be in the red cells. They must be in 2 green cells, and they must then be here. So these are the 2 green cells. That's 8 or 9. Because if this were the green cell, the problem is that would mean these both are not green cells. So we have blue here, green here. This must not be blue or green. It's red. This can't be red or green here, so that's blue. No blue or green here, so that's red. This can't be red or blue, so this is green. That's interesting. That was actually very cool. One of these is green. We don't know which. It could be both, actually. We could have 8 and 9 there. But in box 1, we definitely have 8 and 9. And then we don't know about these, right? Oh, that's interesting. If this is the 8 or 9, it's green. So then that can't be green, which means in column 2, we are missing an 8 or 9. Well, it would obviously missing an 8. Does that help much? I don't really know. Anyways, Red is two digits here. So 4 is in 2 colors. We're not sure which ones, though. Oh, these cannot be... Oh, that's interesting. These can't be red or... These cannot be green, so it's red or blue here. Huh. Red or blue. These are all red or blue. Obviously, these are red or blue. Not green, red or blue. These are red or blue. Huh. That is interesting. That means at least 2 out of 5, 6, and 7 cannot be green. It could be all 3 of them are not green. But at least 2 of them are not green. Hmm. Um, hmm. Huh. Hmm. Ah, this blue and this green cannot appear on this Renban. So in box 1, they must appear in these red cells. So they must be able to swap colors, which means it cannot be 5, 6, or 7 here. It's 3 or 4. This is not 5, 6. This is 2 or 3. 2, 3, or 4 here. Because 4 has 2 colors. 3 and 2 both have 3 colors. And they must be able to be in those cells there. That is interesting. Huh. Hmm. That was really cool, actually. These 2 digits. Also, one of them has to be here. One of them has to be in one of these. This one could be in any of these. This one could be in any of these. If this were 8, this would have to be a 9 here. So this would not be green, which means green would have to be here, and this would be an 8, 9 pair. So this would not be 8 or 9 there. Hmm. Hmm. Interesting. Hmm. This is not green. Okay, this is blue and this is green here, which means this has to be red here. That's interesting. Hmm. What else do we have? If this is, oh, that's interesting. If this is green, this obviously can't be green. These can't be green. So how, this is green and 8, 9 is what we're assuming. Therefore this can't be green. We need a 9 somewhere in a circle in column 2, so this would be 9, that would be 8. This could not be 8, so where is 8 in this box? It's one of these two, so this can't be 8, so therefore this would be 9. Hmm. 9 could not be here, therefore this would be 8. That would be 9. This would be 9 here, then. And this would not be 5, 6, or 7, interestingly enough. Because this green here, we don't have any more greens in this box. Okay, these have to be different colors. So we're going to mark one as yellow and then one as pink. And they're blue and red. So this can't be pink. It has to be yellow here. This can't be yellow, so it must be pink there. So that's interesting. This one could be any of them right now. This can't be yellow, so this is pink or green here. This is blue, so this is red or green here. So if this is red, this would have to be green there. That seems fine. Not too helpful. In every row and column, except for one, we have to have 2 greens. Okay. And box. In every row and column, except for one, we have to have 2 greens at least in each row, column, and box, except for one. No. Because this could be green, green here. Oh, that's interesting. In row 8, we are guaranteed... that's not helpful. Okay. Maybe that is helpful. Okay, in 3 of the rows, we are guaranteed to have 3 greens. Because 3 has to appear 3 times in 3, right? In a green. In row 2, we are guaranteed 2 greens at most. That's actually very interesting. Row 2 has 2 greens at most. Row 8 has 2 greens at most. Row 6, we have 3 greens at most. Huh. Okay. So we could have multiple greens in column 1. Or sorry, row 1. Row 2, we have 2 at most. Row 3, we have 3 at most. So we're going to count the number of greens sort of in this corner. 2, 3, this is 4. This is 3 here, 3 here, 3 here, 3 here, 2 here, and this is 4. So unfortunately, that's still possible. Okay, what happens if we have the most amount of... Oh, that's interesting. What happens if we count them? We know... So 1, 2, and 3 are guaranteed to have greens in them. 8 and 9 are guaranteed to be in green. So that is how many green circles do we have? Guaranteed. 1, 2, and 3 is 6 plus 17 is 23. So we have guaranteed 23 green circles. How many for these maximum amount of greens do we have? 4, 2, 3 is 9, 3, 3, 3 is 9, and 3, 2, 4 is 9. So that's 27. Because of that, we only have 27 green cells at most. 5, 6, and 7 cannot be in a green cell. Because 23 are already taken by the 1, 2, 3, the 7, and the 8 and 9. If we had 5 with that, that's 28 green cells required, green circles required, and we only have 27. 28, so 23, which is the 1, 2, 3 plus 8 and 9, plus 5 is 28, which is 1 greater than the number of green cells we can have, right? This is 4, because we have green, 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 and this could be green. This is 2, because only one of these can be green, because then if one of these is green, that means the other one cannot be. Same with this. We could have a green here and 1 green here. 1 green here, 1 green here, 1 green here, 1, 2, 3 there. This could be green with green there and that green. That's 3. One of these is green, one of these is green. That could be green. That's 3. Green here, and then that's green, and then 4 here. So we cannot have 5, 6, or 7 be green. So that means this has to be 2, 3, and 4, which we have a 2, 3, 4 triplet now in box 1, which eliminates 3 and 4 in the rest, 2, 3, 4 in the rest of the box. So this cannot be 2 here, no 2 here. 4 still could actually be green. Because if 4 were green, then we would have to color everything else green, essentially, right? That's interesting. Can we count them in each column, too? Maybe not, but... We're gonna go... Let's use row 3. So we could have 4 at most in column 1, 2 in column 2, 4 in column 3, 2 in column 4, 1, 2, 3, 4 in column 5, 1, 2 in column 6. We could have 1, 2, 3 in column 7. In column 8, we have 2. In column 9, we could have 5. So 5, 2, 3 is 10. 10, 28. Okay, so it's less per column. Or sorry, it's more per column. We are guaranteed in rows, though, that it has to be 27 at most. Interesting. What about per box, actually? Does that? We have 3 here. This is 3 at most here, so it's 6. 3 at most here, that's 9. 1, 2, 3, 4 here, that's 13. 2, 15. 3 here, 18. 3 here, 21. 2 here, 23, 26, 3 at most here. So again, 1, 2, 3, 1, 2, and 3 here, 6, 1, 2, and 3 here, 9, 1, 2, 3, 4 at most, 14, 1 and 2, 16, oh, 16, oh, never mind. I miscalculated. I think I had 15 here. And then 1, 2, 3 here, that's, so it's 16, or 13 here, no, 15, it is 15. So 3 here, 3 here, 6, 3 here, 9, 4 here, 13, 2 here, 15, 1, 2, 3 here, 18 at most, 1, 2, 3 here, 21 at most, 1, 2, 23, and 1, 2, 3, 26. 4 cannot be in a green cell because we require 1, 2, 3, 4, 10 digits, 8 and 9, which is 27 digits, and we can only have in each box 26, according to the boxes, 26 green cells. So 4 cannot be here. It must be a 2, 3 pair here, which eliminates 2 and 3 in the rest of the column. So 4 has to be one of these digits here. Cannot be here. So we're guaranteed 4 is, this is 2, 3 as a pair, which forces this to be 4 here. And 4, it has to be blue and red as a combination. There's no more 4 in row 1. We are guaranteed we need a 4 on this Renban. So 4 has to be one of these 3, which means 4 cannot be anywhere in column 9. So 4 has to be one of these digits on the Renban. So we're guaranteed 4 there. Okay, so then we don't need that one. We don't have 2. This is, so we know we have 26 green cells at most. So 5, 6, and 7, 2 of them are blue. 1 of them's red. 4 has to be blue and red. And obviously 2 and 3, 1, 2, and 3 all have a green, blue, and red combination. So this, if this was green, we know 2 is one of these. Interesting. 3 has to be here, which means 3 cannot be here. So 3 has to be here, which means that can't be 3. These can't be 3. So 3 has to be one of these 3, because every Renban has to have 3 through 7 guaranteed. Yeah. So this cannot be 3 here. That means this can't be 3. This is 2. This can't be 2. That's 3. So no 2 here. That's a 3, 4 pair here. So 4 has to be one of these 3 digits. We already knew that, though. One of these is 8 and 9. One of these is 5, 6, or 7. So in the green circles, you cannot have 5, 6, or 7, or 2 or 4. It has to be 2, 3, 8, and 9 in the green circles. Interesting. No 5. This can't be 2. No 5, 6, or 7. So it's 8 and 9 here. No 2. No 5, 6, or 7. It's 8 and 9 here. So this is 8, 9 as a pair, which means this cannot be 8 or 9. Here, we have to have 8 and 9 on this Ren band. No, we don't. We do not. We have to have 8 on this Ren band, so this cannot be 8 here. Okay. Interesting. Hmm. 2 is one of these 3. Okay. So that means we actually only have then 23 green circles. Okay, so then we don't have that many restrictions on where they can be. Okay. Not too helpful there. Interesting. Okay, whatever 5, 6, 7 is here has to be here in the Ren band there, which means it must be here in the Ren band there, which means it must be here on the Ren band there. These blue and red ones have to be here. So that's actually very interesting. So let's make this A, and then we'll make this Y and Z. A has to be one of these digits here, which means cannot be here. So A is one of these 3 digits here, then one of these 3. Y and Z are here, which means Y and Z are there, and Y and Z are there. Okay. 2 in row 9 have to be here. So this is guaranteed to have a 2, which means this cannot have a 2 here. But we don't... Oh, 2 can't be here either. Interesting. So we are guaranteed at 8 here. This must contain 3 through 7 and 8. And then we have 2 or 9 here, and the other 2 or 9 has to be there. All right. Okay. Hmm. And we need a 3 in a circle in each row, column, and box. Okay. This, so we have yellow, pink here. Obviously, this can't be pink. So then this is yellow, which means this has to be pink. Interesting. This cannot be 3. We have 1 blue and 1 red for the yellow and for the Y and the Z here. This has to be either the red or the blue. But we don't have another one in this renban. So therefore, this must be one of these digits. So it cannot be 3 here. So this is Y or Z. These are the same. So this must be a 3 that's blue or red. We don't know. Interesting. 4 eliminates 4 here because this can't be 4 because of 4 in the column. We have 1 more green 2 available. We don't really have that many restrictions on it. Four can be in red or blue. So this does not have to be a blue here. It could be red. We do have to have a blue here, though. That is interesting. Because we have 5, 6, or 7 there. We cannot... Okay, so if this is green, this is guaranteed to be red, and this would have to be blue. So we'd have 4 as a red there, which is possible. Oh, that's interesting. If if this is a if this is a 9, that means you could not have 8 and 9 in circles in box 5. Which means in every other box, you would have to have an 8 and a 9. So you would have to have an 8-9 pair here. You'd have to have it here. You'd have to have it in every other box, essentially. If this were a 9. If this is not a 9, then this would be 2. You'd have to have 8 and 9 here as a pair. Actually, how... Okay, so... If this is 9, we have that's 8, that's 9. We need a 9 in the box here, so that would be 9, that's 8, that's 9. So no 8 here. Oh, that does not work. There we go. If we had a 9 here, where is the 9 in box 5? It has to be not in any of these circles, but we know 9 has to be guaranteed in any circle, so this cannot be 9. This is 2. That's the only other green 2. That means we cannot have a 2 in any other green cells. So this must be 8, 9 as a pair here. because 2 is no longer valid here. So this must be 3 through 9. And this must be a green, and it must be 8 or 9 as a pair. We have 2 here. We do not have 2 anymore as a green cell. So this cannot be green because 4 can never be green. 5, 6, and 7 can't be green. So these have to alternate. So we'll make these, I don't know, dark and medium. So these have to be opposite colors here. This is 8 and 9. That means this cannot be 8 or 9 here. So we are guaranteed an 8 or 9 in one of these 2 cells. Because we have an 8-9 pair here, so these cannot be 8 or 9. Okay. Two everywhere else cannot be green. So 2 has to be one of these 2. That doesn't really tell us too much. We know one of these is a 9. So that's why we knew that this couldn't be 9 here. Okay. 9 has to be one of these 3, which doesn't really help us much, but we know that at least. Oh! This can't be 8 or 9. It could be 3 as a green. That is possible. This could be 8, 9 as a pair. 3 has to be in one of, I guess, these 4 cells here. 3 has to be in one of these 3 cells there. Not too helpful, though. So this could be green. It could be dark or medium. We don't know. It can't be medium. This is either dark or it's green here. We don't know which. This could technically be a 3 here and be green. What else do we have? So we have at least one blue here. 2, we don't actually have any of the blue or reds set. So we don't know where those are. A is definitely blue. But that doesn't really give us any information in row 9. Because 4 could be red or blue. 2 could be red or blue. These digits cannot be 8 or 9. It can't be 4. So it's 1 through 7, but no 4 available. 1 cannot be in the circles because we have all the 1s in circles already. So it's 2, 3 with 5, 6, or 7 possible. Oh. We have on each of these red bands 5, 6, and 7 on these circles. That means we have only 1 more 5, 2 more 6s, and 3 more 7s in circles that are not on the red band. That's interesting. Um, hmm. These two digits must be in two out of these three cells, and the last one is a 2. Okay. These two cells. Hmm. Yeah, it's not so helpful here. This was really restrictive, which was nice. This is not as restrictive, unfortunately. Can this actually be an 8? If this were 8, this could not be green, and 8 would have to be here. So I don't think this can be an 8. So again, if this is 8, that's green. That means this is 9. This would have to be 8 here, so that would force this to be 9, which make that 8. But where is 9 in column 2? It can't be here because that can't be green anymore. So this cannot be 8 there. So this is not 8. Which means 8 has to be one of these two digits, so this cannot be 8 here. Interesting. Hmm. Oh, we have an 8-9 pair in column 5, too, which means this can't be 8 or 9. So this has to be 2 through 7 there. We could have an 8 or 9 there. One of these, though, has to be a 9. That's interestingly enough. Because there's no other place for it in column 4 in a circle. Hmm. This digit is the same as that digit there. Hmm. We do know actually. Oh, we can start labeling these. So we'll make this, I don't know, E and F. Let's make that. So this is E and F. This can't be F, that's E, which means this can't be E, that's F, which means this can't be F, that's E. So we have E here, F here. E means this can't be E, so that's F, which makes that E there. So then F has to be one of these two. E is here, E is here, so E has to be one of these three. Now that's interesting. E is here, E is here, E is here. E is here. E must be one of these 4. E must be one of these 4. F has to be one of these. Okay, so this cannot. Oh, this cannot be 8 or 9 because of the 8-9 pair in the column. So this could be 1 still, but this has to be an 8 or 9 here, so this is green. So this is F. This cannot be F. But it still could be E. F is here, here, and here. Interesting. Huh. Um, hmm. E is here. So F in box 7 has to be one of these two. Um, hmm. This is interesting. Anyways, remaining digits in column 5, 1 through 7. No one here because of 1 in the row. 3 cannot be in a non-circle. So no 4 here. No 3 here. No 1 here. Interesting. 4 can only be in a non-circle once, interestingly enough. This cannot be 1, 2, 8, or 9, so it's 3 through 7 there. Hmm. 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 This is red green, so this cannot be green here. This is blue red as a pair. So these must be opposite blue reds. But that doesn't really tell us much. This could be both greens. These could be both greens. So you'd have 8, 9, 8, 9, 8, 9, 8, 9 as a possibility there. Hmm. 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 Okay. Uh, um. Where is E in... Interesting. Where is E in box 8? It must be one of these two digits. That's interesting. That means E cannot be here. E is guaranteed to be one of these two cells there. You could have an EF pair here, though. That is possible. Hmm. Box 1, box 2, box 3, we have 8 and 9 each in those boxes in circles. We don't have any information about 4. We don't have any information about 5. We don't have any information about 6. Box 7, we are guaranteed 8 and 9 have to be in Box. Oh, wait. E is guaranteed to be here. F cannot be here. No, that's not true. F is one of these two. Never mind. Never mind. Um, hmm. That's interesting. So if this is E, F can't be here. F can't be here either. If this is E, that's E there. This would have to be F. This would be a 3. So F would have to be one of these two. I mean, it seems possible. Hmm. Hmm. Remaining digits. Row 2, 1 through 7, obviously. No ones anymore in circles. This can't be 4 because of 4 in the box. It's, well, could be this, whatever Z is. That could be 4. We know one of these two digits is a 9 in column 7. One of these two digits is a 9 in column 6. That doesn't really help us much. Hmm. Huh. I guess where are the possible nines? 1 there. This is 4. 2 there. 2 there. 1, 2, 3 there. 1, 2 there. Okay. What digits can this be? If it's 5, 6, 7, it cannot be the blue. So that doesn't work. So this is 4 or 9, interestingly enough. If this is 4, it's red 4. If it's not 4, it's 9, which has to be green. So that's interesting too. Non-Renban circles. We have, or non-8 and 9, I guess. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are enough threes, though. There are a lot of threes available. And then there's 4 twos, and then there's 4s. So that's not going to be helpful. Yeah, the problem is that the 3s have to be in circles everywhere. Oh, this can't be 3. Yeah, we can't have the 3 anywhere that's not in a circle. Um, hmm. 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 F is either here or one of these 3. E and F. So F cannot be here. F is one of these 3. This can't be F. If this is F, this can't be F, which means F has to be one of these 2. But we know F is guaranteed to be in a circle at least 8 times. And in this case, then it would only be guaranteed to be in a circle 7 times. So F cannot be here. We are guaranteed F has to be one of these 3 cells. That's interesting. Huh. That was very interesting. Hmm. F could be any of these 4, though. That's not that restrictive. Oh, F can't be here for the same reasoning. If F is here, F can't be here, so guaranteed F is one of these 2. So this can't be F, which means this has to be an F here, because there's no other place for F in row 5. So this is F, which means it's not 3. This has to be green, and it's 8 or 9. So F is here. This obviously cannot be F. No F there. That's interesting. F, F, F. We know F is one of these 2. So F is guaranteed to be in one of these, in a circle here, circle here, circle here, circle here, and circle here. So the question for F is, if it's 8, it's guaranteed to be one of these 2. If it's 9, it has to be one of those 2. But we don't have as many. Oh, I think you have the same problem with E. Well, but E could be here. But if E is in any of these spaces, the problem with that is if E is here, that guarantees E can't be here, so E would not be in a circle here. Same with these. Oh, that's clever. So this has to be E, and it cannot be 3 here. That is very clever. So therefore, E is there, which means this cannot be E here. E has to be here, and is green with the 8 or 9. That's very clever. So if E were any of these cells here, the problem is that would guarantee E cannot be any of these. So E would be outside of a circle here and outside of a circle here, but we know E is guaranteed to be in 8 circles. So therefore, that this being outside of circles in both box 4 and box 5 guarantees there would not be 8 and 9 there. So E and F both have to be, so E can be outside of a circle here. Now that's interesting. You don't have any guarantees here, right? E can't be here, so E is guaranteed to be in, oh, well, this both can't be green, so this has to be green here, and this must be, one of these is E or F, so it's 8 or 9. So this cannot be 3 here. This has to be E or F, we don't know which is 8 or 9. And one of these is E or F with 8 or 9. This is green, so this cannot be green here. There we go. And this is blue or red. So this cannot be a 9. Where is the 9 in box 9? It has to be here. So this cannot be dark. It's 9. So this is 9. Which means this cannot be 9 there. 9 also eliminates 9 here, so that's 3. So this is not F, which means F has to be here, and this cannot be F here. So this is... Why do I have A? It's not A either. So this is a 4 here, because this is an 8-9 pair here. So this is green. It's 8 or 9. Let's remove those things there. This is E. This has to be F. This is E. Let's remove the 9s because that's not helpful anymore. 8 and 9 as a pair. 4s here. This cannot be 4. This is A, so yellow has to be blue. So yellow is blue. So this cannot be Y. Pink has to be red. So this is not Y. This is Z. So no Z's here. This is 3 and Y. 3 eliminates 3 from being here, so this is Y. Therefore, that makes this a 3 here. No more 3s here. No more 5, 6, and 7s. It's 2, 4 as a pair here. 3 eliminates 3 here. So this is 4, which makes that 3. 4 eliminates 4 here, so that's 2, which makes that 4. We still don't know if that's blue or red. This is 9. No 2, or no 3 here because of 3 in the column. No 3 there. No 3 there. 4 has to be one of these 3. That doesn't help. So this is not green. This is red. Okay. So this is 9. 8 does not appear in a circle in box 9. Therefore, 8 has to appear in a circle in every other box. So this cannot be E here. This is guaranteed to be E here. So this is not E here. This is F. So that means this can't be F here. This is green and is 8 or 9, so it's E. This has to be green and is F, so no F here. So E is one of these two. We have F there. Where are the F's? We have F, 1, 2, 3, 4. We know where the last F has to be. It has to be 9. Right? We have F in 8 positions. We know where the last one has to be. Can't be here, can't be here, can't be here, can't be here. So F is the 9. So we know F is 9. E is 8. So we don't know which one of those it is. So E is 8, which means E is here. Where is 8 in row 8? It has to be here. So this is 8, which means this can't be 8, so that's 8 there, so that's green. This is a blue-red pair now. We don't know which. Okay, so we are very close to solving this now. We have all the 9s, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have all the 8s, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and this is the only 8 that's outside of a circle. 3s... 3 is one of these two. 3 cannot be here. 3 is one of those two. That's not that helpful. This is blue as a 3. We have 3 4s in red. That's interesting. This can't be 4 because of 4 in the row. So this can't be green. This is blue or red. So these have to be opposite colors here. I guess I don't know, orange and yellow, who knows? These are opposite colors. Cannot. Okay, remaining digits actually are 5, 6, and 7. Oh, this has to be blue then, right? It cannot be the Z, and the only other 5, 6, and 7s are blue. So this must be blue, which means yellow is not yellow, it's red. Okay. This is 2, 5, 6, or 7. 2, 5, 6, or 7. So this must be a Z2 combination. So that means we cannot have 2 or Z. So this is 2 and Z. 2 and Z guaranteed here. That's pretty clever. Z obviously can't be there. This is red. No 2 here because of 2 in the row. So 2 has to be one of these two, actually. Oh, one of those 3. Never mind. 4 cannot be here because of 4 in the row. 3 cannot be here because of 3 in the row. So this is Y or Z. We don't know which. Interesting. And we don't know if this is A or Y. This is the other A or Y. Remaining digits are 2, 5, 6, 7. And so this must be 2 here. This is Z. One of these is a 3. We don't know what the other one is. Where is 2 in row 6? Can only be here. No, could be here. So it's one of those 3. But that eliminates 2 from the rest of... Oh, well, 2 eliminates 2 there. All right, so there's that. Remaining digits of row 4, we have 1, 4, 5, 6, 7. And 1 cannot be in the circles. Remaining digits of row... Okay, so we're just 5, 6, 7. Remaining digits of row 5, 3, 4, 5, 6, 7. No 3 here because 3 is in a circle guaranteed. 3 eliminates 3 from the rest of this row. Okay, where is 3 in row 3? It's in a circle, so it has to be one of these 2, which means this cannot be 3 here. So this is Y or Z. 3 has to be one of these 2. 3 is one of these 2. 3 is one of... Remaining digits of row 7, 3 through 7. 3 again has to be in a circle, so 3 is one of those 2. Okay. 4 cannot be here because of 4 in the column. 2 can't be here. So 2 is one of these 2. 2's outside a circle there, but we don't have any other information. Inside circle there, circle here, circle here, circle here. That's 4 circles. This has to be 1, 5, 6, or 7. Okay. This is AY pair, but that's not helpful. Okay. Oh. This can't be a 2 because there's no other place for 2 in the box. This can't be 2 because of 2 in the column. These can't be 2 because of 2 in the row. So one of these is a 2, which means this cannot be 2 here. So one of these is 2 here. We have a 4 potentially here. 2 has to be one of these two. We have a 4, 5, 6, 7 quadruplet in column 6, which eliminates 4, 5, 6, 7 in the rest of the column. So this can't be 5, 6, or 7. It's 2 or 3. And this is 2 or 3 here. Interesting. Huh. This can't be 1 because of 1 in the row. Interesting. Oh, 2 can no longer appear in a red cell. We are guaranteed a 2 here in red, and one of these has to be 2 in a red because the other A and Y cannot be in a red circle. So 2 is guaranteed to be in blue. And A is guaranteed to be in blue. So this must be 2 and A here, with this being red in between. So this is red, this is blue, and this must be a 2 here. 2 cannot be here, this must be a 4, and this must be A. To match this, A, 5, 6, 7. 4 is here, which eliminates 4 in the rest of the box and column. 2 eliminates 2 as a possibility here. So 2 has to be one of these 2 digits. Okay. So one of these is blue for the 2. And we know we have all the 2s then in all the circles. The 2 green ones are here. This is red, and one of these is red. This is 2 blue, and this must be 2 blue here, which means we cannot have a 2 in any other circle. So this cannot be 2. This is 2. So 2 is one of these 2. 2 can be one of these 3. 2 can be one of those 2. So that's not that helpful. We have a 3, 5, 6, 7 quadruplet in column 7. That eliminates 3, 5, 6, 7 in the rest of the column. So this is 2 here, which means this is not 2, that's 3. Which means this is not 3, that's 2. So no 2 here, no 3 here. Where's 3 in box 5? It has to be here, so that's 3. 2 cannot be here anymore, so 2 is one of those 2. We don't know which. 2 is one of those 2. We don't know which. This is the blue 2. This is A or Y. We're not sure which. So Z has to be one of these. Oh, we have a 5, 6, 7 triplet, which eliminates 5, 6, 7 in the rest of the row. No 5, 6, or 7 here. It's 3, which means this can't be 3. This is Y and Z as a pair. So we're going to make this Y and Z are opposite colors. So we'll just arbitrarily choose one. We'll make this orange, dark, therefore this must be orange again. You don't know which one. It's not green though. It's blue or red. This is dark, so this cannot... Oh, we have a 5, 6, 7 triplet here, which means this cannot be 5, 6, 7 here. So this is 3. This is Z. No, this is A. Sorry. So this is A here. That's 3 here. It cannot be dark. It's orange because then these have to be different colors. This is blue or red. So we have 2 3s here. It cannot be, well, we already knew it's not green. We have a red here and a green here. Sorry, a red here and a blue here. That means these cannot be orange. We have two oranges here. It matches with the red or the green here. Or sorry, red or the blue here. Which means the last three must be a green. Because these are blue or red. So these have to be dark. Which means three can't be here. 3 is here and is green. No 3 here. It's Y or Z. Z is there. Y is there. Z is there. Three eliminates 3 here. It's 5, 6, or 7. We don't. A is here. So this is a YZ pair. Y can't be here. We know this is Y and Z. A is here, so that makes this A. So this is a YZ pair. This can't be Y because of Y in the row. So this is Z, which makes this Y. Therefore, Z is red. Y is blue. This is 4 and A as a combination, but we don't know which one's which. Okay, this is Z, so this cannot be Z here. It's Y. This cannot be Y here. It's Z. So therefore, this is red. This can't be red. It's blue. So we have Y here, Y here. Y could be here. This is not dark, so this has to be orange. So this matches... Well, we don't know. It could be A also. Oof. These are different colors. But we don't know which one's which. So Z appears one more time here. Z is here. So Z cannot be here, which means this must be a 2. So this cannot be 2 here. It's Z. That leaves a 2 here. So no 2 here. This is Z. This is Y. We have 4 and A potentially. We don't know which one's which. This is Z. Z, 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 Z. So Z has to be at least a 6 because it's in Ren bands in all 4 Ren bands, and it's in these 2 cells. So Z has to be. We'll sort of remove. Oh, this is Z. So this cannot be Z anymore. This is Y, which means this can't be Y. That's Z. So Y is blue. So orange has to be blue. And Z must be in red. So dark is red. Okay. So this cannot be red here. So this is blue. Z now is in... Again, it's in 1, 2, 3... Z. Z cannot be here. So this has to be AY as a pair, which means this is Z here. Okay, so Z, we have 8 Z's. We know where the last Z has to be. It has to be here. So Z has to be in circles 7 times, and this is red. Oops. This is red. So not 4. That means this can't be red, it's blue. So Z is in circles 7 times. That means these cannot be 7. So let's look for 5, 6, and 7. Actually, I guess we could just remove 7 from everything. We know where 7 is. Okay. So 4 has to be one of these 2. We have 5 and 6 then. A and Y. Okay. This is 1, 5, or 6 here. Where is 4 in box 5? It must be one of these two, so this cannot be 4. This has to be A, which means this can't be A here. It's 4 there. So no 4 there. We have 4 reds. 4 red circles. So that means the circles can no longer have red in them. So this must be blue. This must be blue. We have Y. This could be A or Y. This is A. This is Y. This is A. A cannot be here. A cannot be here in column in box 5. So A has to be here, which makes this a Y there. So this is A there. We have Y and 8 here, so this cannot be 5 or 6. It's 4. A is one of these two. We don't know which. A is here. A is here. A is here. Okay, so Y, I believe, is in 6 cells, right? We have 1 on each Renban, and then these 2. So Y is 6. So this is 6, and A must be 5. So A is 5. So no more 5s here. And 6, we already have all 6 cells in circles. 1, 2, 3, 4, 5, 6. So this cannot be 6. This is 4. This can't be 6. It's 5. This can't be 5 or 6 because of 5 in the row. So this is 4, which makes that 6. No 6s here. 6 eliminates 6 here. This can't be 5 because of 5 in. So I think that's all the 5s, right? In circles, 1, 2, 3, 4 on the Renbans in this cell. Yep. So that makes this 1. That's 5 and 1 there. This can't be 1 or 5. It's 6. No 5 or 6 there. It's 1. No 1, 4, or 5. So that's a 6. And that's a solve. I always find these Circus Maximas very interesting. They logically, it's never that difficult. And actually, actually completing it, it's not, I don't think it's, I do feel like, I don't know, maybe it's just from my personal thinking, but it's not that hard to execute on it. It's just that it takes a long time to go through all the different combinations for, I've done a decent amount of these circus circles. I don't even know if it's but these 3-ring circus or circles, 3-ring circles. I guess it's 3-color circles or 3-color rings. I don't even know. I don't know why it became a circus, but maybe it's a combination of circles and 3 rings because you have 3 colors. But I've done a decent amount of these, and they never are that logically overwhelming. So they're not logically very difficult, and they're not execution-wise. They aren't places where you can really mess up very easily. It seems like you have a pretty good flow throughout if you have the logic down. But the thing is, it always takes a decent amount of time. So I guess I always place these as very hard. But the actual, difficulty of it and of the actual logic and the execution isn't that hard. But it always takes a long time to actually solve. So for actual difficulty, I would probably place it at hard difficulty, but it's always takes a long time. But it's always satisfying, too. So I've done a decent amount of Jeff's set settings, and they're always very well, they're very, very well constructed so that you always feel like you're flowing through, and it always is satisfying at the end. I don't know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.